what I'm going to discuss today are the ways in which the built and natural environment influence each other, and how through geoarchaeological analysis we can extract social information from building materials, specifically earthen building materials, to investigate past construction practices, especially focusing on the mud brick architecture in Crete. Due to the time frame, as Maya announced, I will give you glimpses of different techniques and results. They are in no way exhaustive of the variety and the range that geoarchaeology can achieve, but I look forward to the follow-up discussion. So without any further ado, earthen architecture, let me actually earthen architecture is a widespread phenomenon, both in the present day and in the past, and it's one of the most amazing expression of our ability as humans to create a unique built environment from humble natural resources. Mud bricks and other earthen building materials are made of soil, water, and vegetal timber. In Crete specifically, we see that a variety of range of earthen building material have been used during the Bronze Age, specifically during the Minoan period. So we are not always only talking about mud bricks, but we're also talking about plasters, ceiling, roofing systems, mortars, as well as earthen building materials. They function as a multifunction element, from door jambs to leveling layers, to complete roofing systems. So the aim and the objects of this presentation coincide actually with some of the aim and the objectives of my PhD dissertation that now ended 5 years ago, and was to investigate Bronze Age earthen architecture using geoarchaeological and architectural analysis to provide fresh insights into the social behavior of the people actually manufacturing these architectures. So the main question is to look at bricks. The main approach is to look at bricks as part of material culture, and we were trying to answer some different questions. One was if raw materials used in mud brick manufacturing change over time from the early to the late occupation within a single site, if the manufacturing processes change over time, and if comparing different sites, we can detect that different settlements use different manufacturing techniques. Now, I know that some of you have heard me talk about this before, so how passionate I am about mud brick architecture, but I often use this fresco that actually is coming from a tomb of a vizier of the 18th dynasty in Egypt as a sort of breakdown explanation of the chaîne opératoire behind mud brick manufacturing. And it's quite important because I think it will explain why geoarchaeological approaches are essential to investigate earthen architecture, because every single action that you see here displayed, from the selection and the collection of the raw sources, of how the mixing is taking place, to the molding and the drying, all these action, all these steps are actually reflected into the final artifacts, in this case, the mud brick, and can be detected through geoarchaeological techniques. So the choice of one vegetal temper versus the other is reflected in the final product. Some of the actions that mud brick manufacturer actually using during the molding, these are also reflected in the final, in our case, archaeological evidence. So for this study, I focus on three main case studies: the site of Monastiraki, Malia, and Gurnia, and a variety of architecture within these sites. For the site of Malia, I took samples from the Palace, Quartier Mu, and Quartier Delta P, the area Maya was investigating. From Monastiraki, I look at both the south and the eastmount, but the samples are mainly coming from the eastmount. And from Gurnia, I took samples from the new excavation, the Gurnia excavation project that started in 2011, so mainly from the northern part of the site, but as well from some of the previously excavated areas, such as neighboring A and the Palace. Just to give you an idea of the variety and the quantity of materials that I have analyzed, roughly at the end of this research, we were looking at 12,515, if I remember correctly, fragments that have been analyzed macroscopically, but of these, a subsample and 120 samples were actually analyzed microscopically, and these are the samples which we are discussing together today. So these are some of the techniques that I actually employ, the geoarchaeological specific analysis. And today I'm going to discuss with you the X-ray fluorescence, X-ray diffraction, and thin section petrography, and give you a bit of a glimpse on what FTR and SEM-EDS have helped us discover regarding Minoan earthen architecture. I'm pretty sure everyone here is quite familiar on how portable XRF work, but I wanted to give you a bit of a rationale why I choose this technique versus the benchtop. And one of the main advantages, it was the fact that portable XRF is a non-destructive technique. And as the samples that, the 120 samples they were quite limited in size, it was important to use non-destructive technique whenever possible. And as you will know, there is a XRF gun, and the way this actually works is actually shooting one specific point in the sample. The X-ray hit the samples. The sample emits an X-ray of a characteristic wavelength that is absorbed by the detector, telling us which elements are present in that specific point of the samples. So portable XRF is a point and shoot technique. To have any reliability, we need to take more than 1 point per samples, because we're not able to homogenize the sample and have so the information that we need to perform statistical analysis, therefore. And here you see one of the first principal component analysis, a type of statistical analysis. These are the variables that I consider, which are explaining roughly 65% of the total variability. And you can see immediately that in this statistical analysis, it reflects how different geochemical fingerprints the bricks that were part of this study present. So the different clusters do not overlap, do not touch. So clearly there is an indication of unique geochemical technique for all of these sites. When though we change the variable that we are considering, for instance, we try to look at possible overlapping between domestic, public, and when I say public, I mean actually palace buildings. And the workshop, we see instead there is an overlapping. So there is a commonality of those sources, but also the tighter cluster of public and mixed context building indicates that these tend to have a better screening in the raw sources, or I should say they tend to stick to the same raw sources over time, whereas as we expected, we have a wider variability in the domestic context. I will not have the time to go through all the different case studies, but I just wanted to give you an example from Malia, in which in this case, you see what I just presented as a general characterization for all of Crete, just on the case study of one side in Malia. And you see that there is an overlapping between the Palace, Quartier Mu, and Quartier Delta P, with an indication that you have the wider variability within Quartier Delta, which is the pure domestic context in this specific area. Similarly, when we look at how these confidence ellipses overlap using as a variable the different time frame. So in this case, we have the neopalatial and protopalatial. The prepalatial samples were far too few to actually give us an indication, but I thought it would be interesting to map them for this presentation anyway, to give an idea where they were actually clustering in our statistical analysis. But you see that the neopalatial and the protopalatial samples are actually, the two ellipses are actually overlapping each other, indicating a commonality again of the raw sources, but also the tighter cluster of the neopalatial period seems to indicate that the raw sources were progressively reduced and adhered then for the whole neopalatial period. And this is not just a phenomenon that we see in each single site, but it's quite a widespread phenomenon. I just want to let you know that and give you another example of how different statistical analysis confirm the results that I just ran through, the PCA that I just ran through. This is an example of a triangular scattergram in which iron, rubidium, and strontium are mapped together. Strontium is a proxy for the carbonate content in the mud bricks, whereas rubidium represents volcanics, micas, and elliptic mud, and iron is clearly represents the non-carbonate silt detritus. And also in this case, you can see there is quite a tight clustering, the famous geochemical fingerprint that I was mentioning in one of my first comment on the first PCA. So when we combine the result from apart from this observation, then when we combine the results from the PCA, from the XRF, portable XRF analysis with the X-ray diffraction analysis, we notice that it's not only possible to determine the type of raw sources, but also possible to actually have a clear understanding of where these raw sources were coming from around each of the case studies presented, and when compared to the geology and geological map of the area. In this case, you see a spectrum that represented the samples that are taken from the Malia Palace, with some of mineral recognized, such as the type of clay, but also the plagioclase, the quartz, and the calcite. And here you see the original, where the samples were taken and how the sample was actually homogenized before analysis. Here you have an example taken from another area in Malia, but also some of the samples. The analysis was actually performed in all the samples in Gurnia. The results of this analysis, when compared also to soil samples, was our ability to identify raw source procurement within a 3 kilometers average 3 kilometers radius from each of the sites. In the case of Monastery Rock, is actually quite a tighter circle. It's a 2 kilometers radius, but in the case of Malia and Gurnia, it's within the boundaries of the 3 kilometers radius. If we look even in more detail at the case study of Malia, we notice that from the center of the site, and with center of the site usually I mean roughly the palace, within the 2.8 kilometers radius, we do have all the raw sources, and we could identify some of the clay beds that were actually used, possibly used in the mud brick manufacturing. Next, we try to identify, as with the XRD, we noticed some peaks, for instance, of calcite, which type of aggregate, which type of human-induced tempering was actually used as calcite. And this was made possible by the use of FTR and SEM EDS. Specifically with FTR, we could identify that the calcite was coming both from shells, marine gastropods, but also from lime plaster that was actually reused and fragmented within the mud bricks during manufacturing. So a clear case of reuse of building materials. In this case, and I thought it was interesting to show you this SEM photo. This is actually a photo taken from a similar brick. In some cases, the conflagration Minoan mud bricks went through, it's quite evident, like you see in the stereoscopic image, the one in the center. So you can see clearly that there's been a fire event. But in some cases, it was a lot more subtle. And in this case, thanks to the SEM, it was possible to highlight the popping of the silica already in the SEM photo. With the petrographic analysis was another set of data that we could combine with the previous analysis to build our knowledge regarding earthen manufacture during the Bronze Age. Apart from identifying different fabric and in some case sub-fabric at each case studied, one important element that petrography helped us with was identifying different types of human-induced tempering. In this case, you see shells, and I'm sure Rina then will give you a lot more information regarding this, but also it was possible to identify, as I mentioned before, we identify with the FTR that the calcite actually was a match both for shell but also for lime plaster, but thanks to the petrography we could verify and confirm this evidence. There are also other type of information, like some of the microfissures that were visible in these micro photographs were actually caused by the progressive evapotranspiration of the water-lane sediment, as in this case, one of the selected vegetal temper, the seagrasses that were used in the bricks, cause long-term water retention. You can also see in the micro photograph on the bottom part of the screen a section showing a weak bedding alternating between clay and silt dominated and clast dominated layers. And one important element though is the huge variability that you do have between the different bricks, which actually it's already providing us some information regarding the possibility to have different skill levels in the people that were manufacturing these bricks. Here are some other examples. These are some of the voids that we usually associate with vegetal temper, as well as one interesting, I find it particularly interesting, I hope you do as well. This is a rotating feature that through some experimental archaeology we reconstruct is associated with the typical kneading done with the thumbs that the mud brick manufacturer actually perform during the molding of the bricks. And in this, the previous slide, I actually mentioned the presence of vegetal temper, and this is possibly the most interesting aspect of this research, or at least it was for me. The fact that we could see that chaff, the traditional temper used in mud brick architecture all around, not only the Mediterranean, but also Asia, Africa, and Americas, different type. It was not the main vegetal temper in Minoan Crete, or I should say, it got progressively replaced from cereal chaff to the use of seagrasses. Here you have examples, macroscopic photograph examples from the 3 different case studies, Monastiraki, Gurnia, and Malia. And when we look at it a little bit more in detail, we notice that one specific species was used. In this case, the species was identified with Posidonia oceanica, that is endemic in the Mediterranean. And if you've been to Crete, you know it's easily found on the beaches almost all year round. So one of the key questions that we try to answer, it was actually why this species was progressively adopted, because, for instance, in Neolithic mud bricks, we still see the use of chaff, and we see the use of chaff in other forms of earthen building materials, such as mud plaster, but also tiles, for instance, all around the Minoan period. Seagrasses are just used in the mud brick manufacturing, and their initial use is dated to the pre-palatial, but we have too few samples to say that this was an endemic phenomenon, but we can attest this becoming more and more popular phenomenon in the proto-palatial period, where Posidonia oceanica were used alongside in these 3 case studies to chaff, and it became the preferred vegetal temper during the Neopalatial period, at least at the site of Malia and Gurnia. We don't have this type of data for Monastiraki because we don't have any reconstruction after the destruction of the proto-palatial period. But we see, even though Monastiraki was 25 kilometers from the sea, that Posidonia will also use, especially in the ceiling and in alongside chaff in the mud brick manufacturing. But we identify not just Posidonia, also other species of seagrasses in other Minoan sites, such as Palacastro, thanks to the study conducted by Maud de Volder, but also Catanzacro, Chania, as well as Festos. So one of the key questions is try to understand if this was an opportunistic choice, seagrasses were available, or if it was also a technological choice, as seagrasses were actually improving the type of material that was used in construction. I ran some experimental analysis on to try to test mechanical, thermal, but also various properties that, in this case, specifically Posidonia oceanica was adding to the bricks. And some of the results, this is actually the thermal curve, but some of the results indicate, and if you're interested, there is a recent article that I published with detailed information. We noticed that there is a clear mechanical performance improvement. So there is an increase in plasticity with the use of Posidonia oceanica. There is a slightly better thermal performance, but there is just a 2-degree improvement. But one, and maybe the best characteristic, the best feature that the addition of seagrasses to the mud brick recipe, it's actually bringing to the table, it's the slow water release. The slow water release implies that this brick took longer to actually dry, and we can see then some deformation that is happening when the bricks were actually put into construction. It's a clear result, a consequence of this slow drying process. But this also increases the ability of the bricks not to crack, which for people who have run any type of architectural project or experimental archaeology project with brick, they know that one of the most problematic aspects of it is actually to slow the drying process so that the bricks can actually perform better once they're used into construction. One added properties, it's the antimycotic properties of these specific species of seagrasses, and the salt efflorescences that are quite, they're present almost in all the sites I'm describing, also indicates that the Posidonia collected from the beach were not washed actually with fresh water before being added to the mud mixture. In this case, adding salt that can cause some problems in when we are thinking at the long performance of these materials. But there is an interesting technique that has been studied both in Tunisia, Libya, and specifically in Egypt, in which salted clay has been used in not only Pizé, but also for mud bricks. And in this case, that showed that salted clay with high level of salt already embedded in the structure actually better performs than unsalted clay in some of this climate. And this has a lot to do also with the temperature and the phenomena of evapotranspiration. So when some of these natural features actually align, salt and that it would be interesting to see if this was the case also during the Bronze Age for Crete. Salt is not a problem, as it usually assumed to be in earthen construction. So some general final observation regarding this study, it's that the use of portable XRF XRD indicate a consistency in soil procurement within each single site, at a chronic consistency. Petrographic analysis help us to identify the quantity as well as sometimes the quality of vegetal temper and other human-induced tempering, and give us information with the kinesthetic evidence of action taken during the Chien opératoire. But specifically, the introduction of sea grasses during the protopalatial period provide us with new evidence that we have some sort of specialization to different level, though, all around the island of Crete, or at least a community of practice that has been created and that is actually sharing this knowledge all around Crete. And they tend to take over in the Neopalatial period. I think it's quite important to highlight how after the Neopalatial period, we do not have sea grasses anymore in the mud bricks. They tend to die down, and already in the post-Palatial, we mainly have chaff again, and that's also the case for later periods. And I hope I am actually managed to stay in the time that you kindly gave me, and I just want to thank this is a study conducted, but it was not possible without the help and support of a lot of the people who are here present today, but also some who are not. So my thanks to all the people who facilitate this study, and thank you all for listening to me and talking about bricks for 25 minutes.